Okay, it's 15 past, so let's start. So we're very pleased that we were able to organize this webinar together with Eurogeographics. My name is Antti Jakobson. I'm the current program manager of the Geospatial platform project that has been running since 2017 and is now going to be ending in end of 2019. And I also have Teemu Saloryhtä, who has been working in this project on the implementation of the services. So it's going to be two presentations. I will start with giving the results and some of the learning points that we have learned during these years on building of the Geospatial platform, and then Teemu will be showing live demonstrations of some of the services. So we started to show some of the additional services as well, but before we actually started. So let's start. So basically, the Ministry of Agriculture and Forestry started this activity based on the previous government digitalization funding that they put some money on the digitalization of the public government part, and that was 100 million euros in total. And from that funding, we actually got 8 million euros to start doing something called Geospatial platform. And why basically they wanted to start to do this was that we were in the situation, of course, that we have been promoting the use of geospatial data quite a long time, but actually some of the data that exists in the society was not very much used. And one of the areas where we were lacking the usage of the data at the government, let's say at this national level, was the municipality data. So we saw that there's a lot of good data in municipalities, but it's not available for many users. That's one example. The data teams that they wanted to concentrate, one of them was buildings. The other one was the traffic network. Also, addresses were quite important, and we have some certain issues on the address data. Also, we thought, or they thought that this land cover, land use area is something that has to be improved. Of course, municipalities also have some services on that. And also areas where we have satellite images or imagery data. That was one of the areas. In this picture, you see some of the 3D data that we have created for one of our cities. This is city of Pori, and that is something that we have been also working within this project. So when we think about geospatial data, we of course, everybody knows that geospatial is everywhere nowadays, and especially in those areas where societies want to improve services for their citizens. And for one example is this smart city, and you can see from the picture that there are a lot of services that actually require geospatial data, and that was one of the outcomes or basis for creating this project, that we realized that we have to work with ecosystems, and these ecosystems are of course dealing with their own things, that they are developing something that they want to develop, but in most cases they all nowadays want to utilize geospatial data. And we in this picture, we have kind of categorized the situations where this geospatial most cases are benefiting the society. One case is the citizens, of course, and the services targeted to the citizens. There's a need to have a situational pictures in many areas. for example, security areas. And if you think about how to get benefit from the geospatial data, the automation of the process is one area, and then this data-driven management. And for all of these purposes, there's a need to have good data. And what we have been trying to do in this project is to get this data that is available from regions, from municipalities, government agencies, especially, and put it available as harmonized data. And then when we have created this geospatial platform, we have realized that certain key components are needed to do this data interoperability. One aspect is the data standardization. So we need data schemas. What we have maybe not many have put effort on those areas yet is that we have been working on quality rules. We also have been working with life cycle rules and collection guidelines, and we now can say in the end of this project that this has been successful. So we have created this kind of harmonized, INSPIRE compliant specifications for Finland that are meeting those needs that the society today needs, and also are utilizing the data coming from various providers. In addition to that, we have realized that the current data probably is not good enough. So we need automated data tools for the producers. So we need automated services for checking the quality. So we have created a service called Quality Card, and a demo will be later showing how this works. But also we need to manage the data lifecycle. So we have created service that actually does that. Even the current producer doesn't manage the life cycle at the moment. So we will set the persistent IDs when this data is coming to the platform, and we will manage the data onwards on that. And by doing that, it actually enables us to provide linked data for the various usages. Also, we provide error reporting back to the producers and some data updating tools for them. So this project has kind of proved that this kind of works. Then we have provided a data portal for finding, evaluating data. We have created this kind of situational picture. Metadata search and certain quality dashboards are planned. It's not currently implemented, but it will be implemented later. So basically what we say is that there's a need for users to understand data, and basically we have to take a step a little bit further than the current metadata services are providing. Then for the data distribution services, we have realized that these new APIs are the key. So basically we will use this OGC new APIs, and also we realize also that we have to probably customize APIs further. So it's not perhaps enough that there is one API for every use. So we have to think about various ecosystems and target the APIs for those ecosystems. We have started to do something with linked data. That is still a little bit question mark. Is that something that the user community really wants to use? But we have started to provide first services on the linked data, and then we will show some examples of that. Then finally, we have realized that there's a strong need for support. So we have been thinking how to start doing innovation on this, and we also have been providing some e-learning modules for example, for government employees, how to actually start using data. And of course, we have to manage the ecosystem, and we call this geospatial ecosystem, and we think that there's a need for doing cooperative development We are open as a default, so this ecosystem is open, but we also realize that we have to manage the security and take into account the GDPR issues, which are becoming more and more important every day. Another picture showing what we actually say is that when you are thinking about managing certain things, we have to we basically need the common specifications. We need joint tools for that, and we need support on networks. And then the government has created this, it's called interoperability platform for managing these common specifications. It's not something that we have developed, but we will put our specification into this interoperability platform, and then our tools are available and services are available to put these things to the geospatial platform. And then we need the support and networks for others to provide this data for example, for government agencies. It's not enough to just publish the APIs. It's actually, you need to provide support to realize that something will happen. Unfortunately, there's one sentence that I didn't translate, this muut alustat, these other platforms. You also realize that there has to be, or there will be many other platforms where we actually have to be connecting the geospatial platform. So basically, what we are saying here is that this interoperable geospatial data ecosystem that we have created has to work with the various data ecosystems. And of course, this is just a starting point. So 3 years is not enough to make everything reality. And what we have been starting to do is that we have created these specifications. Now we have to start working together with various players to actually realize these data ecosystems in reality. We have also made some investigations why we need this interoperable geospatial data, and basically our investigation shows that about only 22% of the economic benefits are realized today. We have come up with a very high figure of the potential benefits of using of geospatial data in various ecosystems. It is 13 billion annually, and only 3 billion has been realized. And then what is the role of geospatial platform in this game is that it's about 400 million euro annually when this ecosystem is fully in place, and that is the year 2025. As I said, we need common specification as a basis, and maybe the new thing here is that we have also created the 3D specification for buildings, also created these life cycle rules and the quality rules for those, and that is something that was not in place when we started to do this. We play with the European interoperability framework, and we say that the benefits increases when you start to manage your processes, organization, and legislation. And one great thing is that you work on the quality and work on your life cycle rules. So it's not enough to have these APIs without working on the processes and the organizations. Then what are the services for the data ecosystems that we provide is a bit difficult picture. We will be showing some of these services that we are running. The main services maybe is this quality card data upload service and lifecycle management service. So these are the key points, and basically when you're utilizing those, then you can start providing these other services. We are basing the user identification within the general government identification, and then there's also some other services that, for example, Inspire services that we provide for those data providers. And this is the list of the of the teams that we are currently working on. Then from the data users point of view, there's certain common services and certain data ecosystem specific services that we provide. Teemu will be showing this intelligent data and service directory, also this data dashboard called Suomigrammi or Fingrammi. These modern, he will be also showing some of the modern APIs, and then we have also these classical services like Suomi.fi, showing these map interfaces for government agencies, etc., and also the Inspire services. Where to start? This is the data discovery, and for that one, we, as I said, we have created this intelligent data and service discovery, which will be using the metadata plus the vocabularies that are existing. And now we are working on including the semantic content of the data for research. And we also have provided the Google support so that basically people using the Google search will find the metadata more easily. Then we need the services for the data providers, and the quality card and the lifecycle management are key on that one, and that is currently available for buildings and for these regional detailed regional plans are utilizing currently that service. We have created certain user interfaces for managing the addresses and creating new information for addresses, and this is going to be a crowdsourcing application for getting the entrances to the buildings and also the waypoints to the buildings. That is something that is currently not existing in Finland, and also this is an application where people can actually inform that an address is wrong. As I said, the Suomi.fi maps is the basic use case. This has been around a few years already, so it's targeted to provide the government agencies actually the possibility to utilize this Google-like maps, and we will be thinking that we will provide in future these 3D buildings, address searches, etc., maybe also detailed plans for those services. As I said, linking with other data is important, so we are providing these APIs for the developers. We are going to start providing the change-only updates based on these persistent IDs, provide the time series data. We have started to provide this linked data with HTML cards, and Teemu will show an example of that. And of course, we need to be connecting with other data, and we already provide a statistics service where you can connect your statistical data to administrative units that we are providing, and provide an automated. It will provide an automated geospatial data on that, and then we also have geocoding service that we provide. And we have to also work with other platforms. We have created some use cases and benefits analysis of those. So basically, this project has not been working on these end user cases or use cases, but basically we provide examples how you can work with data with health and social services, working with government permits, working with 3D and point clouds, working with farming and controlling, and also with crisis management. So what would be available in 2025? We think that the ecosystems would have started to use and realize the geospatial platform. It means the tax authority, food authority, regions, health and emergency services, forestry, built environment, and security. Data would be available at once when the data is updated in the municipality, region, or government for various users. And we think that end users would have started to use change-only service. Municipalities are the key users, and we would have implemented an innovation platform as well. From the data ecosystems point of view, it means that the buildings and structures would be all 3D in Finland. We would have a new base data for detailed planning, plus point clouds available. We would have a new digital plans available. Address data and building data would be corrected because there's certain mistakes in those, and we would have introduced new teams, and we would have solved certain issues with the Inspire services. So that was my presentation. We are targeting to have a world's best interoperable geospatial ecosystem. You may challenge us, of course, but we want to work together with you, of course, and we can discuss that later on. Now we can move to the demonstration part, which is Teemu Saloriutta, and he will be demonstrating some of our services. And then later after that, we will be able to take some questions and comments. So Teemu.
Okay, thank you. And good afternoon also from my side. Let's see if I can take the control of the screen. No, somebody has to give me the control. Yes. Okay, now you should see my screen. So let's begin with a set of buildings. Here is 59 buildings from Helsinki city. And if you look at this looks very good. Quality is okay, right? But let's see, is it actually that good? Now this is the user interface of our Quality Garden data upload service. We have two almost similar forms. This one is for the Quality Guard, and the other one is for data upload service. Don't let the Finnish language disrupt too much. Let's select the Quality Guard. I have here a test organization which has this dataset configured, so each of these datasets has to be configured to this service. It uses FME software in the background where the actual quality control and data model transformation is done. This is the Helsinki demo geo package. Yes, this is the right one. And then we go to this demo folder and I select this chipped file and send it there. And then we have this kind of report page where all the Quality Guard reports are stored and also reports of the data uploads. Now I cheat a little bit. We don't wait for this going through the dataset, but instead I open the report from yesterday where I used the same dataset. So let's see, we have 59 buildings there. It took 8 minutes to complete that. Okay, it was quite slow. Usually it's a little bit faster. And this says that there are 27 errors and 4 notes. So 59 buildings and 27 errors. That's quite a lot. And there is a button where you can download a shapefile which includes all the errors and notes. So you can open them, for example, here in QGIS. Let's see, I have the file there already. You can see the black dots over this building. So each one of these black dots represents an quality error or note. If we check the attribute table, there it tells a little bit more information about each error. So there are problems with the topology of the data. And this says that there are overlapping geometries. So almost all of these errors are actually overlapping geometries. So if we look a little bit closer, there are buildings which are very close to each other. So most likely the person who has created these buildings has created a little bit overlap for them, and that is against our quality rules. That's why there are errors. And about lifecycle management, if we would upload a new data set over this same area, then if there are new buildings or some building is changed so much that it's considered a new building according to our lifecycle rules, then it would get a new persistent ID. But if the whole building is changing only a little bit, then it creates a new version of the same spatial feature. And we save the whole history of the feature from the creation to the end, so that we can later on follow the situation through the history. If we start this or next year, after 10 years of this, we can actually like create how the world was 5 years ago or 10 years ago. That's one important aspect that was not included in the old topographic database. Okay, let's take the next one. Next presentation about this linked data and place name info card. You have place name search here. Let's select Ivalo Airport, which is a good example because it has 5 different names, one in Finnish, one in Swedish, and also 3 different Sami languages. And this info card includes a map which shows the location of this place, and then it has information about all the names which are related to that place. So if you click one of these names, it tells information about that. It tells this is a language is Northern Sami language, and it's official language in that municipality, and it's minority language also in the municipality, and also tells the version number and URI, which is the persistent URI for this specific name. And we have created this kind of forwarding that if you click this persistent ID, it will forward into that info card. And that's how the persistent IDs work in that kind of application. So that kind of info cards will be possible to create also for other teams if they have also persistent IDs, and that's what we will do in the Geospatial platform, that each feature that comes into the platform gets the persistent ID to follow its life cycle. Okay, and then the third one, as Antti mentioned, that we are creating all the services based on these new OGC APIs, especially this OGC API features for delivering vector data. And currently, we have tested these services with the old topographic database, but we are also creating services for each team of the new database when they come to the production. But here is how it looks like when we have all the collections of the old topographic database in this OGC API. And I'll show how it looked when we actually use the data. This is easy because you can actually show everything in this web browser. You don't need any specific software to get the data. We just take natural springs in Finland as an example. Just copy paste this URL and put their parameter limit -1. Then it finds all the natural springs in Finland, and we can just copy paste this to Notepad or some text editor and save it as a GeoJSON format, and then we can use it in any GIS software. And of course, QGIS and other software are going to support these new OGC APIs, but it's as far as I know, it's coming to version 3.12, which was not yet available. But here I opened this natural springs dataset in the QGIS. So it takes about 2 minutes to get the data in the GIS software very easily with only a web browser. It's also easy to read because everything is visible in that GeoJSON format. You can like get an impression of what kind of data there is without doing anything too difficult. And that's how it should go in the future, that a software developer just gets the URL of the service and looks what's inside that service, and then he or she can immediately see that if it looks useful. We have also all the attributes which are in the data. They can be opened in the QGIS. Okay, it takes a while because there are 33,800 natural springs. But yeah, that's how the new